welcome everybody. We've got 13 people online. That's good. Later on during the presentation, if you got questions, put them in the chat, and I will handle those after the lecture is given. So this is the April Novice meeting, Houston Astronomical Society, and we are being recorded. So I guess we get on into our presenter, Debbie Moran. She developed a lifelong interest in astronomy, living in Midland, Texas. As a child, where all the scenery is in the sky, so there's nothing out horizon-wise. She's been a member of the Houston Astronomical Society since 1980, where she has served a number of capacities in the past, including treasurer, education chair, and 9 years as a novice chair in charge of talks for new members. She continues to speak frequently in the community on astronomy topics and light pollution. That's one of the big things that we even had a talk today at City Council. She's also a volunteer telescope operator at the George Observatory in Brazos Bend State Park. She actively fights light pollution in Houston and was awarded the Dark Sky International Hoag-Robinson Award in 2017 for her efforts. She has combined her love of travel and astronomy by chasing total and annual solar eclipses around the world. She retired from the Houston Symphony at violin section after 27 years in 2010. So, Debbie, I'm going to stop share, and you can bring up yours.
Okay. Hi, everybody. Before I share, I just want to mention that this is a talk about calendar systems, which really has a lot more to do with mathematics. But I was astonished at the amount of human drama in this talk. I'll go ahead and share it.
Looks good, Debbie.
Okay, all right, thank you. So this first slide has the date depending on your point of view. There's a Julian day, which I will mention later on, which is actually just a counting of days from a benchmark time, which astronomers use. The Julian date, which is a calendar similar to what the Russian Eastern Orthodox religions still use, which is about 13 days off with us. So the Julian date, on the Julian calendar, it would be April 15th today. There's a Gregorian date, April 2nd. There's a Hebrew date, 15th day of the month of Nisan. Islamic dates, the 12th day of the month of Shawwal. And then there's the Chinese calendar date. So this is Ren Chen, we're in the month Ren Chen, which means dragon, second month, 15th day of the year 4724, and we're in the year of the horse, being Wu. So I'm covering all these calendars, which are still in use today, at least on some level, and the history of how they got to be there. And it's actually a very astronomical topic. So, okay, so this is advancing. Let me see if I can advance the slides. We just tried this before. There we go. Okay, so I found this cartoon when I gave this talk years ago, and it says, "That's another meeting you've missed, Bill. I suggest you switch to the Gregorian calendar as we have." So astronomy creates this big problem, and that you have a length of a day, the length that takes the same place on Earth to face the sun again. You have the length of the month, and then you have the length of the year, and none of those are very mathematically related. In fact, each of those is a very strange, not very round number, except for the length of the day, which is arbitrary, set by human beings. So the tropical year is measured from vernal equinox to vernal equinox. And the vernal equinox is the time of year, either in the fall or in the spring, so it's the spring equinox, when the lengths of the days and the nights are the same, and the sun is most directly pointed toward the equator, or vice versa. And that length is not 365 days, it's 365.24219 days, or 365 days, 5 hours, 48 minutes, and 45.974592 seconds. Meanwhile, the synodic month, which is the average length of the month, which is the time from new moon to new moon, is not 28 or 29 days, it's 29.53 days, or 29 days, 12 hours, 44 minutes, and 3 seconds. And then 12 lunar cycles is only 354 days, or 11 days short of a year. And then finally, a day, which is we've divided arbitrarily by human standards, is exactly 24 hours. And that is the length of time it takes the Earth to turn exactly once, plus a little bit of extra that you need to face the sun again. So a sidereal day is exactly one spin. And the stars are so far away that to face a star again, the Earth turns exactly once, effectively. But when we are facing, when we turn for a day, we have also moved partway through our orbit, and we need to turn slightly more than one full time. So that length of time is arbitrarily set at 24 hours or 86,400 seconds. Notice that none of these numbers are very easy to work with when you're trying to devise a calendar. So there are three kinds of calendars to deal with this lengths of months, lengths of year, and lengths of days not really coinciding very well. There's a solar calendar, which we use, which is Gregorian and Julian. And in that case, you don't even try to make the months the same length of time it takes the moon to go around the Earth. Months may be more like 30s and 31s and 28s, as we've settled on in modern times for February. There's lunar calendars, purely lunar calendars like the Islamic calendar, where it's all based on months. So a new year starts, you have everything's based on seeing the new moon, and a new month starts when the new moon starts again or when you see the new moon. And they don't care where the months fall along the year. So big festivals like Ramadan can fall any time of the year. They can be in the fall or the spring because 12 lunar months do not coincide with the year. Then there's the ones that try to split the difference, do both based on the cycle of the moon and the sun. Those are called lunisolar calendars that would include the Hebrew and the Chinese calendars. And those still have the months being the time it takes the moon to circle the Earth. But then they have periodic leap months, which is actually kind of on a fairly complicated schedule, but works out to where they can keep their festivals like a harvest festival roughly when the spring is, when the fall is, whenever you need to harvest, the spring is, or the fall, and to try to get the festivals lined up. So they just throw in a new month every once in a while. Our calendar's history goes back to the Roman calendar. The Julian calendar was created a little bit later than the Roman calendar in minus 45 BC by Julius Caesar to correct the Roman calendar, which was off by 90 days at that time. So the question is how that happened? Well, in the time of Romulus, 653 BCE, you're going to see at the top different time periods or beginnings of new systems of calendars and how the months, links of the months, and the names of the months even evolved. So in the time of Romulus, there were not 12 months, there were only 10 months. March was the first month, then April, May, and then they had months that were kind of numbered, the fifth month, sixth month, seventh month, and to this day, September means the ninth month, October is the 10th month, November is the 11th, December is the 12th for us, but at those times, Sept means 7, Oct means 8, No means 9, and December means 10. They literally were the 7th, 8th, 9th, and 10th months. Now, instead of having the other 2 months, they had what they called intercalary days. They were like wildcard days, and they were used to kind of fill in. They were mostly scheduled during the winter, and they were used to fill in until you came around to March again. And what's really interesting is that it was somewhat political. So, and sometimes I wish we had this system now. So there was a council that would determine when March would begin again. And if they liked the emperor, they would give him an extra long year. If they didn't like the emperor, they would shorten the year for that particular emperor. And that's how it got off by 90 days. It was really politics. In 713 BCE, we started to introduce the months of Januarius, which is our January and February, but they were still at the end of the year, and that's how they got rid of the intercalary, just miscellaneous days. At least they became months. And as you can see across how the lengths of the months changed over time. By 450 BCE, January and February were moved to the beginning of the calendar, but the numbering didn't really change. So that's why the numbers are off to this day. Again, you've eliminated all the miscellaneous days; those are now 0. And then when Julius Caesar came along, by this time, the year was off by 90 days. So it wasn't starting anywhere near the same time of year that it was supposed to start. And he is the one who introduced the system of leap years. And then when Augustus came along in 8 BCE, that's when the 5th month and the 6th month were renamed in honor of Julius Caesar. So the 5th month became Julius or July, and the 6th month became Augustus or August. So they didn't really have like a beginning year that goes way back. They would have years that were based on the reigns of various emperors. And when a new emperor came along, they would start with the year 1 again. And the years might be named, or that era might be named, the year of the consulship, say, of Caesar and Lepidus. So, for instance, I have found some coins showing what Lepidus looked like and Caesar looked like. So Julius Caesar had to correct everything. There was a big mess of 1 year that was 445 days long to get the year back on track. It had already gotten off by 90 days from where the months should fall in the seasons. And that was called the Year of Confusion. Brutus killed him the next year, and his nephew Octavius renamed himself Augustus, and he introduced the leap years. And this is imperfect. In his case, the leap years were every 4 years without fail. And that's when he added the day in February. And for a while, that would work for quite a while. And they started out wrong. They did it every 3 years for a while. But eventually, and it worked for a while, but eventually, by the time you got to the 1500s, the year was off by 10 days. So they decided to hire someone to fix this. That was Pliny the Elder, he recorded that the Greek astronomer Sosigenes was a consultant. I could not find a coin or a picture of Sosigenes, but I do have Hume Cronyn playing him in a movie there on the right. So what they found is that the leap year being every 4 years without fail would have worked if our days were actually 365.25 days or 365 and a quarter days exactly. But it's actually 11 minutes and 14 seconds shorter than that. So it got off. So it gained a full day every 128 years, or 3.1 days every 400 years. And this was not corrected until the year 1582. And that's when the Gregorian calendar was adopted. And also, like I said before, they had started out doing the leap years wrong. They started out every 3rd year. Then they kind of had some years without leap years. There's a little bit of a rocky period getting the leap years right. But with the Gregorian calendar, they made another correction. So that correction was that if a year ended in 400, then only the years with the end in 00 that are divisible by 400, those were the only ones that would have leap years. And the ones that were not divisible by that would not have a leap year. So that meant we'd have a few years that didn't have leap years, and that would get us closer to more exact with the length of the year without getting too far off. And that's the Gregorian calendar we have now. The days of the week were first proposed by the Babylonians in 600 BC based on the planets, the Sun, Moon, Mars, Mercury, Jupiter, Venus, and Saturn. So even the idea of having 7 days was not around before that. And then Constantine the Great established the 7-day week that we have now for the Julian calendar in 321 AD. So these days of the weeks are named after the sun and the moon and the gods are actually the Norse gods. So Monday, of course, is the day of the moon. Tuesday is the day of Tyr, who's the god of war and is associated with Mars. Wednesday is the day of Odin, ruler of the gods. Thursday is Thor's day, day of Thor, god of thunder. Friday, the day of Frigga, who's goddess of love, or associated with Venus. And Saturday, the day of Saturn. We have Saturn devouring his children. Saturn was considered the father of the gods, or one of the Titans, who are the fathers of the gods and goddesses that we know from Greek and Roman mythology. And then Sunday was the day of the sun. So Dionysius Exiguus, the humble, started measuring the years after Christ's death in 525 AD. So this is when we started having the years measured based on Christ. And this is known as the Dionysian period. That didn't happen until 525 AD. So there was created the system where there's not a year zero, but you have before Christ BC and after death, Anno Domini. And so the real bimillennium, I remember my boyfriend Matt was really getting after me. We should not be celebrating the bimillennium because there's not a year zero. In the year 2001 is actually 2,000 years after the birth of Christ. But that's not nearly as much fun as celebrating in the year 2000. So in 731, Bede wrote the Ecclesiastical History of the English People. In that treatise that they use the same timeline. So that's how we know from history when that happened. And there was they didn't have the term BC yet because he does not refer to a time before Christ, only afterwards. Then in the 17th century, then you had the secularized version terms came up, before the Common Era and the Common Era. So by the 16th century, the Julian calendar had gotten off by 10 days. And there was this big correction in the year 1582, where they just jumped from October 4th to October 15th in order to get this correction fixed, because we had not been doing the leap years correct to keep the calendar on even keel. And people started to panic. They literally thought they had lost 10 or 11 days of their lives, that they were actually going to live 10 or 11 days shorter because it disappeared from the calendar. Then you had the hundreds of years of confusion because not everybody adopted the Gregorian calendar with the 10 days corrected and the new and getting the leap years correct at the same time. So there's a few European countries, Italy, France, Spain, and Portugal, that adopted in 1582. And here's the whole timeline, as you can see. Great Britain was not until 1752. Russia's not until 1917. So it took a long time for all of the world to get back on track and have the date be the same. And what's really interesting is you have this period of time where things are double dated. So here's the Dutch Army marching orders, which were dated for both the 23rd and the 13th of December, 1688. And the other problem was that there was no unity in when the year began. So here's a list of beginnings of years. Alexandrian calendar in Egypt was August 29th to 30th was the first day. Then there are some calendars that started the year at September 23rd because that was Augustus's birth. Byzantine year is September 1st, and so on and so on. Russia went through several beginnings of years, March 1st, September 1st, and then January 1st from 998 to 1700. Western Europe during the Middle Ages began their year December 25th and then March 25th. And England in pagan times began at December 25th. And then England from 1089 to 1155, you finally see January 1st. But then after that, it starts again on March 25th. So here's a tombstone because of these different adoptions of what date it was and what year it was, which is double dated for it's February 15th, either 1703 or 1704. So I have this like fraction, pick your year, because it was close to the boundary of when years could have possibly started based on people starting at different times. So it's still 1703 in England until about March 25th at that time. And now I'm going to jump to some of the other calendars. The Hebrew calendar is a calendar, lunisolar calendar. So the months are the length of the time it takes the moon to go around from new moon to new moon. Days, by the way, actually begin at sunset. They last from sunset to sunset. And back then, in ancient times, the Jews would do the same things as Muslims did. And that was to actually physically see the new moon, which is doable in the weather over there in the Middle East. But quite some time ago, it's been done by mathematics. So if you've got clouds, you still know when new moon is. And for a long time, I wondered how. I knew there were leap months every once in a while, but I didn't know how those were calculated. So that's actually decided by board, but you need 7 leap months in every 19 years. So obviously that's not a regular number of years. You have to have somebody decide when those leap months will happen. And of course, the 12 months don't add up to a full year. The leap month is called the Adar. The is a prefix which means and. The 12th month is Adar, so they would, which you can see at the top, so they would add a Ve-Adar between Shvat and Adar on the leap year. So people who you might notice if you're Christian that sometimes Hanukkah is late and sometimes all it actually coincides with Christmas, and then sometimes at the beginning of December, or even the end of November, that jumps forward again every time when there's a leap month. So the one Christian holiday that has some relationship to the moon would be Easter, which is the first Sunday after the first full moon after the vernal equinox. And it's probably keyed that way because the Last Supper was presumably a Passover Seder. So we just had a Seder last night, and that would have been Last Supper. I believe it's probably the main reason that Easter is one of the few holidays that isn't exactly the same time every year. And the other thing that's interesting about the Jewish calendar, oh, wait a minute, let's see, there's a Matana, is that they switched the beginning of the year. Nisan's the first month, but Tishri is when we have the new year. It actually got switched from the spring to the fall. And when you begin the new year, I have a slide about that. It can only be on certain days of the week. So I'll get to that slide in a bit. It makes some complications with the Jewish calendar. There's also something called the Metonic cycle, which is basically something that makes where all of the lunar phases are coinciding to the same dates of a year, and that happens every 19 years. So what you're seeing right now is all the full moons that occurred on Christmas between 1711 and 2300. As you can see on some of those full moons, there were either partial or total lunar eclipses. And you can also see libation. You can see in this graphic that we see about 59% of the moon because it wobbles a little bit. So we're able to see a little bit more than 50% of its surface over time. And that also had some meaning, the Metonic cycle. So the Metonic cycle is recurs after 19 years or 235 lunar cycles. And it's when the lunar phases occur at the same time of the year. Almost is off by 2 hours, 4 minutes, and 58 seconds too long. And it was first described by Meton in 432 BC. So this is a 9th century depiction of the Metonic cycle. But Rosh Hashanah, which is the first day of the year in the Jewish calendar, cannot occur on a Sunday, Wednesday, or Friday for practical reasons. It has a Sabbath-like, it's a Sabbath-like festival, and you can't work then. So you also have to make sure that you are able to prepare for it. So you can't have a Sabbath right before the Sabbath to prepare for it. You have to be able to do work before it. So there are reasons it can't fall on certain days of the week, and therefore the beginning of that particular month has to be fudged a little bit. So the common years are the ones that don't have a leap month because of that limitation. Could be either 353, 354, or 355 days long. And again, the leap years can also have 3 different lengths, 383, 384, or 385 days long when you have the extra month. And there's terms for that, the chasara, or the efficient year, the ones that are shorter than a solar year, or the kassidra, or the regular year, and the shlama, or complete year. And this, again, I think I mentioned before, is that the beginning of the new year shifted from spring to fall, but the way the months are numbered didn't change. Nisan is still month number 1. So that I did find out, thanks to my boyfriend, that we were celebrating my grandfather's birthday the wrong day of the year for his entire life. We also didn't have the year of his birth right. My parents were telling me it was 1903. He found the birth record in 1902. But at that time, he was born in Latvia, which was under Russia at the time. they still had not switched the Julian calendar until 1918 or 1917. And so his birthday was recorded as August 13th. But Matt told me, look at the Hebrew day. It was 23rd day of Av. And that actually corresponds to, sure enough, August 26th. So the Hebrew day corroborated what Matt said, which is that we were using a Russian Orthodox calendar for his birthday, and that the Gregorian date should have been August 26th all this time. Grandfather never knew that. He died before we ever celebrated his birthday on August 26th. The Islamic calendar is a lunar calendar, but it's strictly lunar. These are the beautiful depiction of the months. Here you can see that 4 of those months, the ones in red, are festival months. Again, it doesn't matter what season it is, they just have to fall in these months. And all of the months are 29 or 30 days, and their year is 11 days shorter than the tropical year. So in Islam, I believe to this day, I had someone who came to my talk a couple of weeks ago who had worked in a number of Middle Eastern countries, said to this day, they still have to physically see the first crescent. Now, we have members of the Houston Astronomical Society who do this as a pursuit, try to see the youngest new moon possible. And that can be affected by the atmosphere, clouds, of course, but to see a very slender new moon very close to the horizon is very difficult if you have any haze at all. And so he was telling me that you can have different countries in the Middle East that are starting their months at different times. Now, it kind of all shakes out eventually, because then you start all over seeing the next new moon for the next month, and eventually everything's sort of back on track. But they do physically see the new moon. And I suppose that custom could be possible in a part of the world where they have an awful lot of clear days. So depending on conditions, the first crescent can take from 1 to 3 days to see after a new moon. And part of those conditions are the reasons we don't have eclipses every month. The moon's orbit is inclined by 5 degrees. So sometimes that tiny little crescent is a little higher above the horizon than at other times of the year. And that can affect when that month begins, or how easy it is to see a very skinny crescent. So as you can see, this is so important in Islam that many Islamic flags, or flags from Islamic countries, there's about 56, 57 Islamic countries in the world. So many of those flags depict that tiny crescent new moon and the heavens. So this is the Islamic calendar, and this kind of shows how it corresponds or doesn't exactly correspond to the Gregorian calendar. And so the beginning of the year, the number of years they count from, is AH, or after Hajj. It's measured from Muhammad's journey from Mecca to Medina in 622 CE. So it's the year 1447 right now. The Chinese calendar has a lot of both astrological meaning as well as astronomical meaning. So you probably know from your Chinese restaurant placemats that there are 12 zodiacal years. We're in the year of the horse right now. But there's also, the months are lunar, they're lunar cycles, and they have a complicated way of inserting a leap month, which I have another slide on. But for both years and even days, there is a mapping of celestial stems or heavenly stems to earthly symbols. But this just shows how the Gregorian date corresponds to a Chinese month. I love the names of the months: corner month, apricot month, peach month, plum flower month, pomegranate month, etc. And a leap month is inserted if there are 13 new moons from the start of the 11th month in the first year to the start of the 11th month in the next year. So this works out to a leap month about every 32 to 33 months, and that's called an intercalary month. There's also a sexagenary cycle that names the days, and also it names the years. So you have something called Tiangan and Dizi. And so the Tiangan are the 10 celestial stems. There's growing wood, timber, natural fire, artificial fire, earth, metal, etc. And then that's mapped to 12 terrestrial branches, which are animals, basically. So there's a 60-year cycle in which they start with, say, Jiazi, which would be wood and rat mapped together, the first of each. And when you come back to Jiazi again, mapping 10 things to 12 things, it's 60 years later. They also do that with days of the month. And they have a 60-day cycle too. So here's a calendar, Chinese calendar, and you can see that mapping. So the day one here is wood snake, then you got fire horse, fire sheep, earth monkey, earth rooster. And in the days, they consider, they divide it into 2-hour periods. So you have the 12 earthly symbols are also 2-hour periods in the day. And apparently we're astronomers, not astrologers, so I haven't really researched the meaning, but each of these pairings will tell you what it's auspicious to do. Is it a good time to marry? Is it a good time to go to the market? Is it a good time to plant? These pairings would actually drive daily activity. So now back to the Julian day, which is the first thing I showed you on the first slide. Since we went through so many eras and there were so many different cultures with so many different calendars, astronomers decided they needed a completely something that has absolutely no ambiguity to it. So they came up with something called the Julian day, so that if someone talks about the Julian day, it doesn't matter what culture you're from or what calendar you're using, they all agree what day that is. And it was decided to measure it from January 1st, 4713 BC at noon. And you're literally counting time in days, minutes, and seconds, and fractions of days from that time, ever since 4713 BC. And that date was chosen as the beginning of 3 cycles which are coinciding. There's an indiction cycle, which is a 15-year tax cycle adopted by the Romans. The solar cycle, which is 28 days, and it's when all the days of the week have been a leap day. And actually, I think it's 28 years. Since a leap year occurs every 4 years in the Julian calendar, then there are 7 days of the week. It starts over again. I think I should have said every 28 years. And then there's the lunar cycle, the 19-year Metonic cycle. And those are all coincide January 1st, 4713 BC. So my almost last slide has everything looks the same on it, except I updated the Julian day for 8 p.m. today. I have the parts of it after the decimal point have been altered since my first slide, which was at 7 o'clock, and because it's actually measuring fractions of days. Now, I do have a postscript. There's the Klingon calendar. And it's really fun how people write fiction, whether it's languages or calendars, are basing what they come up with in fiction on history. So the Klingon calendar sounds a lot like the Roman calendar. I guess they have a different lunar orbit or orbit. They have 48-day months, 9 48-day months, but they have names of the years and the months they measure from eras of various empresses. So there is a Klingon calculator online. So today, actually, I didn't put this particular time. I put like 2 hours ago when I went to do it. But 2 hours ago, it was 6/14/42, day 22 of Caelus. And we're in the year of Caelus 651. And that calendar, you just search for a Klingon calendar calculator, and there's a whole page on how the Klingon calendar is constructed. And I guess that's all I have right now, so I'll stop my share.
Thank you, Debbie.
Okay.
Do you have a slide on how to talk Klingon?
Not yet. That would be another. I know there are Klingon courses, but okay. Well, what I do think is really interesting about the Klingon language, because I found the most hilarious 30-minute lesson from Worf in Klingon lessons. They keep doing the same dialogue, and the guy keeps getting punched out because he keeps saying something wrong. But I was really, after having gone to the Arab world And, growing up learning some Hebrew, it's interesting to me that the Klingon language has sounds from both Hebrew. It has the guttural ch, as in patach, but it also has the Arabic language has two H's. It has a normal H, like we say at ha, and they have a very strong explosive H, where you put the back of your tongue against the back of your palate and say huh. And both of those sounds are in Klingon. And I love that it combines sounds from both Hebrew and Arabic in that language.
If you got any questions, let's see what's in the chat here.
And I hope I can answer it, because I'm not, just research. I'm not a total expert.
We have an announcement from Bill Sparizzi. You want to get off mute, Bill?
Before the meeting started, I saw that NASA officially announced that the Artemis spacecraft started their TLI burn, translunar injection burn, which means they're headed for the moon out of Earth orbit. Although I do have some, first of all, to keep with your topic, I just learned just a few days ago that the word Ferengi, which you may have heard in Star Trek, is Hindi for foreigner. Okay.
Really?
Yeah. That was from my son, who doesn't speak Hindi as far as I know. But anyway, also, some of your calendars are a little confusing to me. So I'm wondering, is tomorrow that's still the date for the general meeting?
No, it's next week. Because Friday, it's
Good Friday.
Good Friday, so they can move it. The next meeting will be next week.
Perfect. Thank you very much. Thanks.
Yeah.
Okay.
And Matt was calling out to me. He was like, I'm like, Matt, I've got to give a talk. He was trying to tell me about the burn right before I sat down at the computer. I did want to mention, though, I did see something, I think just yesterday, and Matt and I used to sit around and listen to leap seconds when they would come. We had to occasionally insert a second so you could hear a 61-second minute. But they dispense with the leap seconds, and now there's a feature saying that we're in a period where the Earth's spin is speeding up slightly, and we may need what they call negative leap second. They may have to insert some 59-second minutes into our calendar. And that was explained. It's because we're we're not a solid object. We're sloshy and liquidy, and you can have various forces on the Earth which temporarily speed us up or slow us down. It's not a constant speeding up, but right now we're speeding up just a little bit. We'll need to take a second out here and there.
Sounds right. Thank you.
Okay. Let me get back up to our meeting announcement. Oops. Okay. We had no announcements here. Let's see. Let me try this again. Resume slideshow. There you go. So I guess no specific announcements, except the main meeting will be next Friday night. And we have all the SIG meetings coming up. The visual SIG is on the 8th, a smart telescope SIG on the 15th, astrophotography on the 22nd, and the new data and science SIG is on the first Wednesday, which would be May 6th. So you can see email from Matt on the subject line for April 2026 SIG meetings. So they all have the same Zoom code.
Yep. Maybe I can add a little bit there, Steve.
Sure.
So we have the main meeting that was moved from this Friday to the week after. So that's on April 10th. Then the day after, so that's on the Saturdays, we have two outreach events, one at JP Landing and the other one in League City. And then we have on April 18th, we have Prime Night at the Dark Side. So that's like the darkest time of the month when most of the astronomers are getting together at the dark side near Columbus. And then for the SIG meetings, be careful that the links have changed because we are now in a new membership year. So just have a look at that email that we sent out with the new links so that you are sure that you can have access there. Thanks. Yep.
Thank you, Matt. And anyway, so listen to Deborah again next week on light pollution effects on human health. There's all kinds of stuff coming out about that, how our bodies are affected by all these bright lights that we're putting up. So join us, general meeting, not tomorrow, but next week, next Friday. And always visit us at astronomyhouston.org for registration details. And you can find us in Facebook and Twitter and Instagram and YouTube, or just send an email to info@astronomyhouston.org. So, any questions or anything?
I just want to thank Debbie for another excellent presentation. You know some stuff. Always enjoy hearing you.
I just researched. So it was actually my boyfriend who got me interested in this. I did this years ago at a SIG meeting. I was like, I've got to get into a PowerPoint form because it was a lot more fun talk than I imagined when I started it.
Well, that was great. And again, thank Matt for his contributions as well. Much appreciated.
Will do. Thank you.
Anybody else want to chime in with anything? No? Well, I guess we'll just say good night. Everybody enjoy it. Take care.